Now in this lecture, we take examples based on the Jacobian. If u is equal to x square, v is equal to y square, then find the Jacobian of uv with respect to xy. We have given that u is equal to x square and v is equal to y square. Let us give it equation number 1 and equation number 2. Then we have to find the value of Jacobian of uv with respect to xy. If we see the equation number 1 and 2, here u and v are dependent variable and x and y are independent variables. So now we want to find out the Jacobian of uv with respect to x and y. So let us define what is the Jacobian of uv with respect to xy. This is nothing but the determinant of del u del x, del u del y, del v del x, and del v del y. Differentiating 1 and 2 partially with respect to r and theta, respectively, we have. First thing, what is the derivative of u, partial derivative of u with respect to x? So the derivative of x square is 2x. Now since u is free from y, so partial derivative of u with respect to y is 0. Now if we come to the second point, del v del x, again the v is free from x, so its partial derivative of v with respect to x will be 0, and the partial derivative of v with respect to y is 2y. Now we substitute all these four values in equation number 3, then we are able to calculate the Jacobian of uv with respect to xy. What is del u del x? Del u del x is 2x, del u del y is 0, del v del x is again 0, and del v del y is 2y. So after putting all these values, we have the determinant 2x, 0, 0, 2y. And now if we simplify the determinant, we have to just multiply this into this minus this into this. So 2x into 2y minus 0, and it gives us 4xy. So this is the Jacobian of uv with respect to xy, which is 4xy of the given functions. Thank you.